I'm Anil Kumar, and here is a test question for you on direct and partial variation. The question is, identify each relation as a direct or a partial variation. Support your answer using a table, a graph, and form of the equation. You can pause the video, answer the question, and then look into my suggestions. So we have three different equations here. So these are the three equations. The first one here is y equals to half x. Then we have y equals to 2 minus x and 2x minus y equals to 0. Now you need to figure out whether they are representative of direct variation or partial variation. Now the first one here is y equals to half x. So it's directly proportional, right? So we could say this is direct variation. Now we need to justify. How do you justify that? From the form of equation, the equation is y equals to k times x, right? So in that, if I put x equals to 0, if x equals to 0, then y is equals to 0. That means the coordinate point 0 and 0 is on the graph of y equals to half x, and that justifies that this is a direct variation. The other way could be that you could make table of values and then sketch a graph. So if you sketch a graph for 0, you get y equals to 0. Let us say x is 2, you get y as 1, right? So you get a graph kind of like this, which is straight line going through the origin, right? So that represents direct variation. And of course, we'll take independent variable x and the dependent variable as y in this case, correct? So that is how you could actually justify direct or partial variation. Now for the second equation, which is y equals to 2 minus x, let me begin by sketching the graph. So you can plot a graph with some table of values. So let us select some values for x and write down the values for y. So if I have x as, let us say 0, so 0 is a good value to take always, that is the x value, and here we have y equals to 2 minus x. If I write 0, I get y equals to 2. If I write x as 1, I get 2 minus 1 as 1. If I write this as 2, y becomes 0. And likewise, if I write 3, I get minus 1, correct? So that gives us a graph. So at 0, the y value is 2, right? So let us say this is 2. So that's the first point. At 1, it is 1. So at 1, it is 1. Let's say that is 1 and 1. At 2, it is 0. Let's say 2. So now let me actually join them, since it is not a good, it's not a graph paper. So it kind of like this, right? So that will be 2 for me, right? So that is how we'll get a graph. Now from the graph, you can say it is partial variation, right? So we have partial variation. Reason is that y-intercept is 2, right? It is not 0, is 2. So the graph crosses the y-axis at 2 and not at 0. That is the reason, correct? Now, second, when you look at the equation itself, it is y equals to minus x plus something, right? So that is a variation minus 1 times, but 2, that makes it partial. Do you understand? So it is not the equation of direct variation. Equation will be y equals to ax, that is direct, and partial will be y equals to ax plus some other constant b. So that is 2. That is why it is not a direct variation. Let's look into the next equation. The equation given to us is 2x minus y equals to 0. We can rearrange, so we get y equals to 2 times x. Now if I substitute 0 for x, or if I check the point 0, 0, then it satisfies the equation. If I write 0 for x, y is also 0. Since it is a straight line, on which the passing through origin, we can say, which passed through origin, we can say this is a direct variation. So that's another reason. You could always sketch the line and then check for yourself. So we have y equals to 2 times x. That means at 0 it is 0, then there will be a steep line like this, right, going through the origin. So that becomes the line going through origin, and since it passes through the origin, it represents direct variation, correct? So that is how you could justify that this is direct variation. So now remember, whenever we're talking about direct variation, we are looking into a relation which is linear. So it's a linear relation, and if it goes through origin, so it is direct or indirect, right? So if it's linear direct variation, then the point 0, 0 is on the graph. But if it is partial, then the point on the graph will be 0 and some other point where b is not equal to 0, right? So it will have y-intercept which will not be at the origin but somewhere else. In that case, it is going to be a partial variation, right? So I hope that helps. Thank you.